Okay, thank you. So my name is Zaib, Kaleem. I'm with Access Agility. We're a systems engineering company out of Virginia, near the Washington, D.C. area. What we mainly do is wireless design implementation work for the U.S. federal government customers, but we also dabble in wireless tools. So we have sort of a side business where we make wireless tools for everyone. The hashtag for this talk is WLPC, plus please add on iPerf3. That way people that are not looking for WLPC but have interest in iPerf3, they'll be able to find this also. iPerf is something that I've used for a long time, and it's been around for 10 plus years. And over the last 5 or 6 years, the newest version of iPerf3 has actually been more actively developed than the older versions. And that's the one that this talk is mainly focused on, which is iPerf3. iPerf3 and iPerf2 and 1 work pretty much the same way. The concept is a sender, or something that sends traffic, and then a receiver that receives traffic. And you use a command line to set up the sender and receiver, and they send data back and forth between the two different host machines. The good part is that iPerf3 is actively developed, but the bad part is that when they re-engineered or redeveloped iPerf3, they started from scratch, and it's not compatible with iPerf2 or iPerf1. So if you have iPerf2 or iPerf1, you won't be able to use iPerf3. You have to install iPerf3 from the source or compile it. iPerf3 works the same way as iPerf1 and 2. The most common way to run it is to do a iPerf -s on the server side, and then run iPerf -c, then the IP address on the client side. And the default settings will run a TCP test for about 10 seconds, I think. And then there are a lot of other options to control the testing. One of my favorite options for iPerf3 is the -r command, which is, I think, only available in iPerf3. What that does is it allows you to sit at the console on the client side and then still have it send from the server back to the client. So it's actually a reverse test compared to what you would normally run by default, which is a client to server test. This will actually run the test from the server to the client. So it's a very nice command feature of iPerf3. So here's a diagram of sort of how that's set up. So by default, if you were to run a client to server test, you would run iPerf -c with the IP address of the host or the server on your machine, which would be the laptop there. And then for the server, you would run iPerf -s, and then they would run a TCP test from left to right. If I was sitting at the client, I didn't want to walk over to the keyboard of the server. I would just run iPerf-c -r, and then it would send the data from the server back to the client. So it's a very nice feature of iPerf3 where you don't have to run around between the server and the client to run a test in 2 different directions. Some other flexible testing options. This is something that's probably more useful for us wireless engineers. One is that you're sitting at a single console, a single client machine, and you want to run a test to multiple servers. In that case, you can run iPerf-c and then use the and command, then run another iPerf -c, and a single client will send a test stream to multiple servers on the other side. Okay? And the exact sort of converse or inverse of that is you can run a test from multiple clients to a single server by running that server as multiple instances of that server on that host on different port numbers. So I think in the afternoon demo that Jerry's doing, he may actually talk about this also and how he set that up. Here's some cases that I put together for how to use iPerf3. It's not only useful for throughput testing, but it can also be useful for some labbing. For example, if you want to generate background traffic for spectrum analysis, you can just use 2 different host machines, select a channel you want to run traffic over, run that test, and then you'll see background traffic as spectrum energy on your spectrum analyzer. Another one is that if you're doing a point-to-point bridge, maybe before acceptance of that bridge between you and your customer or you and your employer, you'd run a test between the 2 points and show that, okay, this 1 gigabit per second bridge is actually meeting that requirement. So instead of relying on just pointing the bridge and seeing signal information, actually running tests between the two different hosts is a good way to do acceptance testing. I'm going to go over some other testing scenarios, but the one that I like to talk about in detail a little bit later on is the client count versus throughput testing. And I think that's the one that most of us really care more about. Again, this is a simple scenario. This is from my talk I did, I think, in 2014, where I had a similar talk, but a much longer talk, where I showed how when you run a single client test between a 2-stream MacBook Air to to a wired receiver, you get about 550 megabits per second if that station is 5 feet away. And for this two-stream laptop, the max would be, or the max PHY would be in the 800 range, but because of overhead and other issues, you're only getting 550 megabits per second or so. If you repeat that test again and add just 2 more stations, a non-wireless person would think that, okay, the 2 other stations combined with this laptop should still get around 550 megabits per second. But based on information that we know about wireless, where they're contending for the air, the data rate's actually much lower and in 300 megabits per second range. So when you're trying to explain to your customers or employers how things work with wireless, a good way to show them is to actually run a test using their clients, using their network, and then show them real numbers and show them why wireless works this way and what the numbers would be. The last scenario that is something that we can talk briefly about, we don't have time to get into it too much, but is client throughput versus client count. iPerf3 is a really good way to show this, where what you can do is set up 30 clients using either a Raspberry Pi or an Odroid or some other type of client on one side, and then on the server side, run tests to that client and show the impact of different settings in your network. You may want to change minimum data rates, change channels, change the bandwidth of the network, of the channel width, and show the impact on data rates for each client. So a way that you can do that maybe is to run a serial test for all your clients. So all 1 through 60 or 1 through 30 clients run by themselves only, and then you get a certain data rate that you see per client. Then you start adding additional clients one at a time, and you would see what the total data rate would be for all those clients after they're added on, and compare that to your total channel capacity and see if you're actually efficient in your settings. Then go back, tweak one setting where you may change the channel width from 20 to 40 and repeat that test again to see if the 60 clients have a better per client data rate or not. And then you can go into vendor-specific settings like airtime, fairness, some other things, and see how their settings compare to other vendor products using the same type of methodology. So again, not enough time to go into it in detail, but there's a link at the bottom of the presentation where I think this was from WLPC Europe, where Robert Crum talks about how they used iPerf3 for stadium validation testing, and they use a similar technique for demonstrating or confirming how their network was tuned or performing for their I think it was a cricket stadium. Now, kind of getting into this whole idea of interoperability project, what does it really mean? If you've ever started trying to compile iPerf3 or compile any iPerf or start using it, you may realize that it gets pretty tricky. There's not that much support out there, and the number of people that are available to bounce ideas off is not that great. So my thinking is that we would come up with a set of minimum standards that if someone is implementing iPerf3 on their product or their physical hardware, they could get certified so that when you were to buy it from them or to see that they support iPerf3, you would have a good knowledge that they meet certain requirements. So what does that sort of mean? So the idea is that we would come up with a minimum number of standards that iPerf3 would need to meet. For example, it should work in client mode, it should work in server mode, it should allow you to do UDP testing, TCP testing, and some other parameters. Define that as the minimum requirement, and then come up with a validation process where the vendor would claim that they meet this minimum requirement, and they would be considered sort of self-validated. And then if they wanted to get lab validated by a community of volunteers or maybe a third-party validation company, they would submit their documentation and their product or their software to that company. That company would validate that iPerf3 is working the way it's supposed to work. And then when you're actually testing using their product or their software, and you use it to make a buying decision for $1 million product, you know that it's meeting certain requirements and it's actually not like a bad implementation of iPerf3. So if you actually promote iPerf3 and you can get it installed everywhere, you can do a lot of testing to verify that your network works a certain way. So in this example here, I've got 8 or 9 different points where you can have iPerf3 installed. I think today it's very common to find iPerf3 binaries already for clients and servers, but it's very hard to find vendors that have added iPerf3 to their hardware devices such as routers, switches, and controllers. And the hope is that if we start promoting iPerf3 as a way to test and to test throughput and to verify equipment performance, many vendors will start implementing iPerf3 also. So how you can help is that if you're a buyer of products, start recommending or requiring that the vendors support iPerf3. If you're a product manager and you're responsible for products that are either software or hardware, start adding iPerf3 support into your products. If you're a customer, request that your vendors give you test results using iPerf3. So if we start talking about iPerf3 a lot in the community, then vendors and other people involved in the industry will start supporting iPerf3, and that'll give you a way to test your product or your network using iPerf3 versus having to build it on your own from scratch or to add on a third-party device into your network to test with. Okay. Thank you very much. And any questions, let me know.
Thank you, Zaib.
All right. Thank you.
Yep, just for a minute. Okay. Brian, you'll be after lunch. I know you were all ready, but that's okay. Just want to ask you a question. Okay. So, to promote iPerf3, what do we have on our USB sticks that's from Access Agility?
So I guess in an attempt to follow what we're telling everyone else to do is to build iPerf3 into their products. We've made a iPerf3 macOS client and server, which you should have on a USB drive, and you have it free for 30 days. We've also have a iPerf3 server client for iOS, macOS, Windows, and Android. So what that means is that that's a no time limited full endpoint that runs as a server on your different devices. You can test between the Odroid or iPerf3 to that endpoint, and there's no charge for that. So we're trying to sort of support this idea that if everyone has a way to test to different devices, it will promote the use of a testing tool to have real data about network performance versus just saying that it's working really well or that it's a great network versus actual numbers for testing.
Thank you very much. I mean, that's